Hello, everybody. Welcome again to our monthly JUG meetings. Here we are in Riyadh Java User Group. On behalf of all of you, I would love to welcome our guest, Eric. Hi, Eric.
Hey, you're gonna have to tell me how to pronounce it. Is it Muath or Muath?
Yes. Well, how are you, Eric? Good?
I'm doing well. I know it's probably pretty late in the evening for you, but it's right smack in the middle of my workday, which is we were just chatting offline, like why virtual meetings are good because you can get somebody from anywhere at any time.
Yeah, good stuff. Nice. So, guys, today we have like a special guest, Eric. He's a Java champion. He's been advocating for the Java community, sharing his knowledge and sharing the Java stuff all over the world. I will leave it also later for Eric to introduce more about himself. We would love also to congratulate also Eric for recently joining IBM. Congratulations, Eric.
Thank you.
Well done. And today we'll be talking about something like everybody is like, it's becoming trendy and everybody's talking about the AI, and yet Java has also joined this race. It's not only Python anymore. So Java has also joined this race. And today we're gonna see lots of beautiful content, LangChain4j and other stuff from Eric, of course. So I'd like really guys to collaborate more, ask your questions. We have also the box below. Drop your questions and we will be trying to answer them throughout the session. And also for you guys, if you'd like, if you're interested to see our previous JUG meetings, you can visit our YouTube channel. It's Riyadh JUG in YouTube, also Twitter, LinkedIn, everywhere. So without further ado, everybody's excited about AI and this stuff. So I leave it for Eric. Good luck, Eric.
All right, thanks very much. And if you wouldn't mind, if questions come in, I'm not sure as I'm going if I'll be able, because I've got multiple monitors here, if I'll be able to see the chat. So if there's something that comes in, just stop me or chime in or whatever. Just interrupt me as the questions come. I'd rather take them as they come rather than an hour from now and then try to remember what I was talking about. So
sure.
Definitely better to do that now. So we're going to talk about LangChain4j. It's a little bit about me. I'm a Java champion. I live in the United States. I'm in New England, just north of Boston. So it's, like I was saying, it's right smack in the middle of my workday. I've been doing software development for a long time. I currently work for IBM. I'm about 3 weeks into my journey at IBM. I was at Red Hat for about 6.5 years before that. Even prior to working for Red Hat and IBM, I worked in financial services and insurance, but I was always involved in open source. So that's kind of been a key pillar throughout my career originally as a consumer of open source and then becoming a contributor in lots of different projects, Spring, Quarkus, LangChain4j, and so on and so forth. I was chatting with Muath beforehand as well that I help organize our local users group meetings. So we run meetings like this once a month. So it's a great way to get involved with your local community. And I always love coming and talking to the user groups because you can have conversations and you can be more informal, and it's a good platform for learning. So like I said, don't be afraid to throw questions out there. I know it's kind of hard with the live stream where it's kind of one dimensional, but let's try and keep it interactive as we go along here. I've also written this book, which has nothing to do with the content that I'm going to talk about today, but you always have to shamelessly plug yourself. So if you're familiar with Spring and want to learn about Quarkus, I've written a book about it, but again, not the point of today's talk. There's also a book out there about LangChain4j that was written by my friend Antonio at Microsoft. This came out, I think, towards the end of last year and talks about LangChain4j. I mean, the speed at which AI moves these days, how much of this has changed since then, I'm not sure. I haven't read the book myself, but the space is moving so fast, which is why you're going to get a ton of information doused through a fire hose today. This talk is actually about a 3.5 hour talk when I do it live at conferences. So we're certainly not going to get through all the material. And I've promised Muat that I'll come back for a part 2 at a later point in time. And we'll figure out how to schedule that, because we're certainly not going to get through everything today. So what are we going to talk about? So there's, you can see on the left here, there's a ton of stuff. Hopefully we're going to get down through image models and maybe into RAG today, and then the rest of that stuff would probably have to punt on for the rest of the day, or for another day. The way I like to do this talk is I like to assume that you don't know anything about AI and explain the concepts behind it from a technology agnostic point of view, and then introduce LangChain4j and what LangChain4j does to try and solve a particular problem, and then throwing Quarkus on top of that, or Spring Boot on top of that, what the sugar that the frameworks provide on top of LangChain4j. But we're going to try to keep it mostly focused around concepts and LangChain4j. So, and I'll talk about that in a little bit. So there's tons, all the example code that I'm going to go through. There's a QR code there, and there's links at the bottom. All the example code is there. The slide deck that I'm using now is available out on SpeakerDeck. It should be there. If it's not, please ping me. And there's also a hands-on workshop where you can actually go and do on your own, which has a lot of the same stuff that we've built. So you can kind of go off after the fact, and if you want to get hands-on and build some stuff yourself through a self-guided workshop, it's there too. And just as a kind of a disclaimer, I tend to like to use humor, and some of the prompts and whatnot that we use in some of these examples they're kind of funny, but they're kind of tailored. They talk about these people, Clement and Georgios and Emmanuel, and whatnot. And just to say that this talk was, I originally co-developed with Georgios Andrinakis, who's one of the project leads for the Quarkus LangChain4j project, and Clement Escoffier is the other co-lead, and he's also the co-lead for Quarkus. The three of us built this talk together, and so a lot of the examples play on our names and play on the kind of our personality. So if you see names like Georgios and Clement and whatnot in some of the code and prompts, that's who those people are. I did this talk once and I didn't explain who the people were, and somebody asked me, who's Georgios and why is it funny? So figured I'd try to explain it ahead of time. So without further ado, let's get going here. So we're talking about AI infused applications, and what is an AI infused application? So I certainly didn't coin the term, but the way I see it is we're trying to take some software and we're trying to extend that software with AI capabilities. And those capabilities, there's lots of different kinds of capabilities. The standard one that we always see is the chatbot, right? So we have, to me, that's where you're trying to use AI to either replace or impersonate or simulate a human behavior. You know, a chatbot, rather than picking up the phone, you're interacting with a chatbot, and the chatbot can do stuff, make some decisions on its own and do some things. So it's kind of like what a human would do. The other way I see it is you can use AI as a capability to replace other software or workflow patterns, or be able to make decisions on how to do certain things, not necessarily that would be done by a human, but that might have been done by a declarative or imperative program at one point in time. So there's tons of stuff that can go wrong, but that's kind of, if you were to kind of separate the two of them, that's kind of how I see the two of them separate. And so when we talk about AI infused applications, we're talking about applications that are now going to use some AI capability to do something, to do something, whatever that something is, depends on what your business is paying you to do. All right. So, but before we can talk about infusing your applications with AI, let's kind of take a step backwards and let's talk about what's the basis behind AI. What are these things that make our applications be able to be smart? And the basis behind all that are these large language models. Right? There's a ton of them out there. This space has been booming for the last 2.5 years. I mentioned I've been in industry for 26, 27 years, and I've never seen the pace of innovation as to where we are now and how fast the space is moving. And just to see, like, every time a new version of a model comes out, like how much better it was in the previous version, it's just insane. But essentially, these large language models are nothing but a neural network that knows how to recognize, predict, and generate text. It's essentially a big statistical model, and the model doesn't know anything about what the context actually is. It's just for every time it produces a word, it's the most probable or statistically probable word based on the context of all the other words. So it doesn't really know what you're doing, and you can fine tune these too. And it's how good one is depends on how much data it has at its disposal and how much data it's been trained on. So data that, or a small model that doesn't have a lot of data isn't going to be as good as a model that has lots more data. But the definition of as good as is not necessarily a static definition, right? It can vary depending on what you're trying to do and what you're trying to accomplish. But the models are huge. So like Llama 3.3, for example, is trained on 15 trillion tokens, and we'll talk about what a token is in a minute. It's not quite, sometimes it's a word, but it might not be quite a word. It's some number of characters. But it's trained on 15 trillion tokens, and it has every time you talk to it, if you think of a slide, I'm using my hands here, but it's got this sliding window of data that it can work with, and it can work with 128,000 or 128 kilobytes of data. And the model itself is 43 gigs on disk. DeepSeek R1, which came out recently or a few months ago now, is 670 billion parameters, 14 trillion tokens. It's a 32K token window, but it's 400 gigs on disk. So these things are huge, and they use a lot of resources. And we'll talk about resourcing in a second. So when we talk about parameters, I mentioned here, you've got 70 billion parameters, 600 billion parameters. The more parameters a model has, it makes it gives it more capabilities that it can do. So if you need a model that's just going to answer questions or do like translation, maybe you could get away with a smaller parameter model. But if you want to do like very specific things like code completion or reasoning or retracing or parsing or pattern recognition, all those things, you need more parameters. So the more parameters you have in your model, the more things that model can do. And we talk about serving the model. The model itself is just the thing that's on disk that has the algorithms. You need to actually run the thing, right? So that it can actually do something. And because these models are highly statistical probability models it's pure mathematics, GPUs are really good at running these things. And if you think about what GPUs are invented for graphics processing is all math, right? At least that's my understanding. I'm not a graphics expert, but it's all math. So GPUs make what we call inferencing, the actual interaction with the model, faster, because the models can take advantage of the high capacity and the high performance that GPUs offer. That being said, you don't necessarily have to have GPUs, but it's definitely a more painful experience if you don't have GPUs. I know I have two machines here on my desk. I have a Lenovo laptop that doesn't have any GPU, and then the one that I'm presenting on now is a Mac M4 Max. And when I work with a Llama or some of these models, the Mac will just blow away in terms of performance. The Lenovo, even though the Lenovo is higher spec with higher CPU throughput and more memory, the Mac will just blow it away because it's got more GPU support. So when ChatGPT first came out, you had kind of this one mega ultra purpose model, which kind of knew how to do everything. And what we've started to see as technology has evolved is that sometimes it's better to have smaller, more specialized models. So rather than building this one huge model that knows everything about everything, being able to come up with smaller models that are more specialized in terms of what it knows about. So in this example here, you might have, you know, a workflow system that knows how to do legal processing, has things with medical documents, knows medical terminology, and then has some technical, maybe you're building medical devices or something, right? So rather than having a single model that that has to know everything about all of these, you can fine tune them. And this is kind of like how microservices evolved too, right? If you think of the original ChatGPT as a monolith, and then microservices came about, you know, what do microservices give you? They give you the ability to deploy independently from one another if you do it right. They give you the ability to scale each capability independently. So if you follow some of those cloud native and microservice principles and apply them to models, the patterns kind of fit. And then you can have routing models in front of them. Either use AI models to do routing, or you use a workflow system or imperative coding to decide what to do to call these specialized models. With the invent of DeepSeek and some of these other, like Claude Sonnet 3.7 and ChatGPT 0.1, we started to see more of what's called reasoning models. So reasoning being able to, when you ask it a question, it thinks about the question. And in the case of like DeepSeek and some of the other models, they actually output what they're thinking, and then they can make decisions and kind of go down a decision tree and try to work through something and figure out, hey, that doesn't actually work, that doesn't actually isn't what you're looking for. It can backtrack up its graph and try multiple paths before it produces whatever answer you're trying to see. So these kinds of models are effective because you don't have to necessarily train them and spend as much time training them, but you kind of pay that penalty of during inference time. And inference time is when you ask the question, you know, because it might take longer to do the inferencing if it's going to backtrack and reason and make decisions. But on the plus side is you can, with some of these reasoning models, you can get better, I don't want to say performance, but you can get better results, like more concise and more appropriate, more accurate results with a model that has less parameters, because the model can reason as part of its decision tree. And so this is something we've started to see come out. And like I said, ChatGPT, the 0.1 and 0.3 models can do this. Sonnet 3.7 and higher can do this. DeepSeek can do this. But regardless of which model you talk about, you've kind of hopefully these little infinity symbols look familiar from a software engineering perspective. You've got these two processes, right? You've got this DevOpsy process for how to build software, which we should all be familiar with, you know, build, test, code, release, deploy, monitor, and rinse and repeat. And then on the data science side, you've got a very similar process for building the models. You've got the training, evaluation, deployment, collecting data, curating data, training data, the actual act of doing the training, and then the deployment part. And at the end of the day, at least from me as a software engineer, I see this very similar to like databases. Like I, as a software engineer, don't necessarily know how the model works, just like I don't know the underpinnings of how Oracle database works or how Postgres works or how MySQL works. All I know is it's a relational database and it satisfies and it has a certain interface. How it gets there and how it gets deployed, I just know I need to connect with it. Are we going to take Java and use Java as part of a DevOps or an ML workflow? Probably not. At least I don't see it. Could you? Sure. There are tools out there to do it, but this is the Python world. These are the folks that are the mathematicians that are doing all the building the Jupyter notebooks and all that. But now you start to say, well, why wouldn't we just do everything in Python? Because, you know, we're not going to deploy Jupyter notebooks and have our users use Jupyter notebooks. You know, all of our enterprise applications, or not all, but a large portion of enterprise applications that are out there today are written in Java. So why would we change that? We just need a way to talk to and interact with these models. But like I said, if you're talking to ChatGPT versus Claude versus DeepSeek versus, whatever other model you're talking about, the interfaces to the models are different. The APIs are different. Every model has a different interface, has a different API. So as a software engineer, that starts to perform, bring a problem, because if we wanted to change, say, from O1 to O1 mini, for example, the interface might be different. So now we've got to go change our code. So what, like everything in computer science, what you learn in computer science 101 is that you can introduce a layer of indirection and kind of solve any problem. So what the industry just needed to do was come up with some kind of client or toolkit that abstracts the models away a little bit so that you don't have to worry about that. And in the Python and JavaScript world, this is LangChain. And LangChain's been there for a while. I don't know a whole lot about it. I've never used it myself, but it's out there. And that's where LangChain4j came from. So kind of one caveat here is there's and I'll talk about this more in a bit, but there's really no relationship between LangChain and LangChain4j other than the name and the origination, kind of the thought process of bringing in a layer of abstraction for these models. Other than that, they're completely unrelated. They're owned and managed by different people, different teams of people. I know LangChain4j, the founder of LangChain4j, works for Red Hat and now IBM as well. I contribute to it. There's hundreds of contributors. Microsoft contributes to it. Google contributes to it. IBM, Red Hat, there's tons of contributions to it. I'll talk more about the relationship in a little bit. But essentially, it's a toolkit to be able to build Java applications that infuse or use AI, being able to provide building blocks to be able to build stuff, abstractions for prompts and messages and memory and tokens. I'm going to talk all about what these things are in a little bit. RAG patterns, document loading, providing abstractions for being able to do that. So it doesn't matter who the provider is or what the API is, it abstracts that away from you. Kind of like JDBC, for databases, the protocol, when you talk to different data, that's where JDBC came from, because every database had a different protocol. So they standardized the protocol. So now all databases kind of speak the same language, but that's not the case in terms of models. Different models have different interfaces and can do different things. Different models have different capabilities too. Not all models can do all the same things. So if we look at the relationship here, you got LangChain on the top and then LangChain4j in the middle. So LangChain4j inspired by LangChain, and that's kind of where the relationship ends. It wants to provide these abstractions and building blocks, but the programming paradigms and the models between like Python, JavaScript, and Java are very different, right? The way you do things and the frameworks that are around are very different. So the way it implements these patterns and building blocks is obviously very different. From LangChain4j is built with a completely framework agnostic view of the world. It doesn't assume anything. It does not assume you're doing Spring or Quarkus or Helidon or using dependency injection or doing Jakarta EE or any of that stuff. It's completely agnostic to any potential framework. So you can use it even without frameworks. If you're just doing rolling plain old Java, you can use LangChain4j. There is Quarkus extensions for it. So Quarkus does have an extension layer and capability layer that sits on top, and we'll talk about some of the benefits there. There is a set of Spring Boot starters for LangChain4j as well. So you can use Spring Boot with LangChain4j. I'm not really involved in that, so I don't know the maturity level, like if you were to compare feature by feature of the Spring Boot integration versus the Quarkus integration versus the pure LangChain4j stuff, I don't know what that capability matrix looks like, but there is Spring Boot support for it. And so I guess here is, I see somebody in the comments talking about Spring AI. I'll talk a little bit about Spring AI here. LangChain4j and Spring AI are completely different things. So Spring AI is built for Spring, only for Spring, by Spring. Whereas LangChain4j is more community driven, is framework agnostic. So with Spring AI, you can only use it with Spring, and with LangChain4j, you can use it with anything. That's kind of the big thing. I know I don't want to get into a feature war or feature battle, and it's been a while since I've even dabbled with Spring AI, but that's kind of the big key difference is If you're familiar with Quarkus and all the build time optimizations and the resource efficiency of Quarkus, you get all that benefit with LangChain4j as well when using Quarkus. And Spring AI just works the way Spring does. For better or for worse, whatever Spring is doing is what Spring AI does. As far as building blocks, so you've at the very low level, you've got these parsers and memory building blocks and prompts and functions and tools and different language models and types of language models. And on the RAG side, you've got loaders and splitters and abstractions for embedding models and vector stores. And we'll talk more about what those are when we talk about RAG. And then at the top, you've got this concept called an AI service, and we'll talk more about what an AI service is. So there's kind of two different programming models with LangChain4j. You can use all the building blocks directly, in code, or you can go up to a higher level of abstraction and build interfaces and use nomenclature that makes sense for whatever the business need you're building is. And this is actually a differentiator. Spring AI doesn't have this concept. So with Spring AI, if you're familiar with like REST template or web client or whatever, and the REST template builders and REST template customizers and all that stuff, Spring AI is built around a very similar concept where you construct I don't know what the name of the class is, but you construct this thing and then you work with it programmatically, which you can do with LangChain4j as well. But there's a higher level abstraction that LangChain4j brings in, and we'll talk more about that when we get into that section. The other thing, some of these frameworks build on top of LangChain4j, where LangChain4j provides all these building blocks, but because LangChain4j is agnostic to the rest of the tool set, what it doesn't provide is if you're doing dependency injection, or you want to do auditing, or you want to have resilience like circuit breaking and bulkheads and retries, being able to do tools and testing and mocking and observability, open telemetry, Prometheus, all this kind of stuff that you need operationally is something that the framework of choice will bring in on top of LangChain4j. Like I said, I don't know where the Spring support is for this stuff. I haven't worked on it, but this is all when you're using LangChain4j with Quarkus, you just get all this stuff out of the box for free without having to do anything. So you want to audit your things. We'll talk about auditing. I have a whole section on auditing and resilience and observability and using dependency injection and the way Quarkus kind of forces you into the declarative AI service approach too, which we'll talk more about. And it's very easy to get started. So if you're just using LangChain4j, it's just a dependency, the main dependency, and then you can pick the dependency or dependencies for the different providers that you're using. So in this case, OpenAI. In Quarkus, you just pick one of the dependencies or more than one of the dependencies that you need, and you get everything that you need. So that's kind of the basics and the structure of LangChain4j. Any questions before we're going to start to get into some concepts here? And we'll start from, like I said, a technology agnostic view, and then we'll kind of talk about what LangChain4j does. No questions? Okay. So let's talk about chat models. So this is kind of the core concept in LangChain4j, is being able to invoke the LLM to do something, right? And so in the case of models, we're talking about text in and text out. You're sending text in and you're getting text back. And that's how most of these models work, which, coming from a software engineering, especially in Java being strongly typed, we're used to strongly typed objects and being able to pass objects, not back to string parsing. So as you're going to see it, and as you start working with some of these things, we're kind of reintroducing some of these problems that we thought we had solved many, many years ago. They're kind of bubbling themselves back up as the ecosystem evolves a bit. So rather than just kind of show slides, for every example here, there's code examples that I'm going to jump down into. And the examples repository that I showed the link for earlier is organized kind of in order as I'm showing them. So like chat models is section 1, AI services, and then there's a bunch of everything is kind of ordered the way I do it on the slides here, so you could follow along. A couple of these are, if you've ever used a tool called JBang, is you can actually create a one class application, and you can put these little annotations at the top of your class, and you can actually make your class executable. So I can just do like prompt dot, oops, I'm in the wrong directory here. It would help if I was in the right spot. one. Prompt.java. And so I'm actually using OpenAI and GPT-4o for all the demos that I'm doing. Yes, I pay for it. Is it expensive? No. I mean, I've done this 3-hour presentation many times, and I loaded my account with $5 about a year ago, and I think I've still got like $1.50 or $2 left. So it doesn't cost a whole lot to play around. So in this case, you can see I built an OpenAI chat model. I have to give it my key, which I'm not going to share, tell it what model. And so now I have an instance of chat model, and I can say chat and tell it what I want to chat, and I can get an answer back, and you can see what the answer is, right? So can you actually see the code? Yeah, you can see the code. Yeah. So there's a someone's asking for the code. I'll put a link right now in the chat for the link. Hang on one second. Yeah, I'm gonna drop this in the chat right now, if it'll let me. No, so I'm gonna post it in our back channel chat here, and the host can post it. So the link says C Escoffier because it's in, I mentioned Clement at the beginning of the talk. It's in his repository, but we all kind of work in it. And that's where all the examples are, and we maintain it and keep it up to date. So if I wanted to use, so this was just straight LangChain4j out of the box, no framework, no nothing. If I wanted to do something similar with Quarkus, I could build a command line Quarkus application, and I could do something very similar. The difference being that Quarkus will actually inject my model for me, right? You see, I'm using constructor injection in all my different prompts because I'm defining them as beans in the dependency injection context. Quarkus will inject them as beans, and now I can use them as beans. I don't have to construct them myself. And so that's kind of one thing that Quarkus will do for me on top. So if I run this prompt with Quarkus, and so now it's a Quarkus app, and you can see Quarkus also provides some configuration where you can turn logging on and off and all that stuff. So what is this doing? So the first thing it's doing is it's chatting, saying say hello. The next thing it's doing is it's saying say hello but it's using a different model. So if you had an application that used different models for different purposes, you could switch one interaction and switch the model that one interaction works. And then the third one, if I wanted to do streaming, all you have to do is in Quarkus change the return type. So instead of returning a string, which is synchronous, as soon as I return a multi, which if you're familiar with Spring is kind of like a flux, it's a stream of non-deterministic ending things, Quarkus will automatically stream that back to you. So you can see as it was streaming token by token back to me. And because I was using Quarkus, it now has some properties that I can set. Quarkus exposes configuration properties, which is something the LangChain4j out of the box doesn't have, because it doesn't make any assumptions about what framework you're using. If you're using any at all, it doesn't provide like property-based configuration. It's all done in code. So the Spring Boot starter and the Quarkus extensions bring in a level of configuration. So now you could configure through your application's property file and set them like that. So you can see I can set the temperature, I can set my API keys, I can set logging requests and responses and stuff. So that's kind of fun. And I talked about streaming. You can also do, if you don't want to do the multi thing, the straight LangChain4j API has instead of a chat model, has a streaming chat model, which you provide this listener, and it has callbacks as things happen. So as a token comes back, it will spit it out to you. When it's done, it'll spit it out to you, or if there's an error, it'll spit it back to you through events. That being said, this is not true streaming. LangChain4j under the covers doesn't do true streaming with back pressure and all that kind of stuff. So you'd need one of the things for LangChain 2.0 is to introduce like the Java Flow API for back pressure support with streaming, but that's not there yet. So Quarkus with the multi supports back pressure, and I think that the Spring implementation will bring that to a flux and supports back pressure and all that fun stuff on the streaming spot. So that's something that the frameworks above and beyond LangChain4j will bring into the max. All right, what else we got here? So So now we're kind of seeing the basics of how it works. What are these things that we're sending back and forth? If everything is text, are there different kinds of text that you can send? And the answer is yes. So there's when you send something, it's called a prompt. And there are a couple different kinds of prompts, and they use the word role to define the prompts. And this is something, thankfully, all the major model providers have at least settled on the same nomenclature in their APIs. Their APIs might look different, but at least they've settled on the nomenclature. So when you see the user prompt or the assistant prompt or the system prompt, it means the same things for all the different model providers. It's just the package structure and the API and how you send it back and forth and what it looks like might be different, but they still use the same names and the same terms. So at the most basic, like we just saw, you send a prompt and you get back a response. So the prompt you send is the user prompt, and the response you get is the assistant response. Right. There's also, when you send, there's another role that you can send a message called the system role, and this kind of has a higher priority than the user role. And we'll talk about why that's important when we talk about memory and message windows and stuff. But essentially, you can define the kind of the context of how you want your interactions to behave. And the example I use is like, say you always want your thing to come back and talk like a pirate, or talk in iambic pentameter, or speak in Greek. You would set that as your system message because you're defining the overall behavior. There's someone's asking about MCP. I've got a whole section about MCP. MCP is a whole different beast. We'll talk about MCP. I don't know that I'll talk about it today, but MCP is a whole different thing. At the end of the day, you can use MCP to discover other AI-based services, but the interactions with the models are still over an API. So you could have MCP servers that disguise themselves, that interact with models, but at the end of the day, those MCP servers are using APIs to talk to that. And that might not make sense right now, but when I explain MCP and how that works, that might make more sense. So, for example, let's go to my examples here. So I have these set up as Quarkus applications, but they're not really, they're just kind of, we're just using Quarkus to bootstrap it. So you can see I've got a system message, and this is where kind of our play on Georgios and Clement comes in. Georgios is from Greece. So your Georgios, all your answers should be using the Java language using Greek letters. The user message is say hello world, and then you say chat, and then you should get your answer back. So and then I do, oops. Oops, I probably got to build it first. That might be better. Even package. Now I can run it. There we go. So now see, it's giving me back my answer, and I said say hello world, but all your answers should be using the Java language. But you notice one thing that it came back is it says, didn't just give me the answer. It said answer and then tick, 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 like in Markdown, Java, and then here's a Java class. And I don't speak Greek and I don't know Greek, so I don't know if that's actually valid Greek or not, but you can see it's definitely not English. I could change the system message and say, you are Eric, all your answers should be boring and long. Right? So now if I just change the system message, oops, I got to rebuild it. Run dev mode. All right, so here it goes. It was just taking time. So here's hello world, indeed, blah, 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 blah. So I could say system message. My system message, Emmanuel Bernard is French, and he's the kind of the chief architect. So we use architectural decision records for everything. So if I ran this again, just by pushing the space bar, it's slow. Yeah, so now the way that the answer comes back, because it understands what an architectural decision record is, the way it's giving, I'm still asking it to do the same thing, to say hello world, but the context of how I want it to behave is different based on the system message, right? And so one thing that will start to become apparent very fast is these, by default, these LLMs are stateless, right? So if I send it a message and I have a communication with it, and then I go back, if you're going to the ChatGPT interface and you say something, then you say, tell me more about that, and use the word that, it kind of understands that that refers to something in the previous part of your conversation history. But the LLM itself doesn't manage conversation history. That's something that the applications built on top of it have to manage for it. So the ChatGPT interface that you're using has something built in to do memory management, right? So as you can start to see, and we'll go to our things here. Let's go to our demos. Manual, we can do some manual memory management if we want to. All right, so I'm just injecting the chat model. I'm constructing a list of messages. One of them is a system message, your useful AI assistant, and then the first message is, hello, my name is Komat, and then you ask it, what is my name, right? So how does that behave? And then you get the response, you print out the answer, and then you add that answer to the memory. And then you add a new user message to the memory, say, what's my name again? And you call the chat. So when you send the chat, you're not just sending one message, you're sending the whole history with it. And then the third time here is you're just going to send a user message to say, what's my name again, right? But without the rest of the memory. So you can start to see as I run this. So answer 1, your name is Komat. Answer 2, your name is Komat. Answer 3 is, I'm sorry, I don't know who you are. Can you remind me? Because when we sent the request, we didn't send the whole conversation history. We only sent a single message. So when I say, what's my, it doesn't know what the word my is referring to, right? So the other thing you need to think about is every model has what they call a window size or a context window. So the size of the memory, we haven't talked about tokens yet, but a token, for now, just pretend a token is a word. Every model has a different token window. So the amount of data that you can send, like the amount of the conversation history. So if a model has a 48K token window, you can't send more than 48K bytes of data as part of your message history because the model won't accept it. It'll I don't know what it'll do. It'll blow up, won't accept it. But every model has a different token window, and so you need to keep that in mind when you're dealing with different models. All right. So luckily enough, LangChain4j comes with some stuff. So rather than us have to manage the memory ourselves, which could start to be a real pain in the what. LangChain4j comes with these ways to manage memory, and one of them is called a message window chat memory. So it's based on number of messages. So in this case, I'm going to manage it based on 3 messages. So I'm going to add a system message, I'm going to add a user message, another user message, and then I'm going to add a couple more user messages, and you're going to see it's going to start to evict things as it runs. So you can say answer 1, your name is Komat, but then it says, I don't know where you live, because you have a message size of 3, you've put 3 things in, and then you added 1 in when you said, your name is Komat into the history, which actually evicts this one. So the system message, because it has higher priority, never gets evicted, right? So, which is important because when the system message is meant to define the behavior of your LLM. When you start talking about windows, you never want to lose that. So if you wanted your AI to always talk in Greek or always talk in a pirate, regardless of if you've exhausted your memory, you always want it to talk like a pirate. If you used a system or a user message to define the context of how you want it to behave, that would be probably the first thing that got evicted when your memory filled up, and now your AI would start behaving in a way you didn't want it to, right? So that's super important. Anything that contextual for your models that you want it to always hold true and always behave in a certain way should be done and defined in a system message, right? Because when you asked it again, where do I live? It evicted the fact of, hello, my name is Komat and I live in Valence, France. So it doesn't know anymore. Make sense? And so here's my token. So every model tokenizes a little bit different. This is an example from OpenAI. So if you go to OpenAI's website, they have a tokenizer. You can put in some text and it'll show you how it's going to tokenize it. And so this word, you can see I've kind of highlighted and colored how it breaks these things down into tokens. So sometimes it's whole words, sometimes it's just characters. I don't know what the algorithm is. To me, I haven't been able to find much of a pattern, but essentially the token is a part of a word. So it's not quite a word, but it's usually a part of a word. Sometimes it's a whole word, sometimes it's not. And so when you build these windows, the LangChain4j API also has the ability to understand how many tokens, because when you make calls to these providers, especially the ones that you pay for, that's how you get charged. You get charged based on tokens. You get charged a fee based on how many input tokens you give it, and you get charged a fee based on how many output tokens you give it. And the LangChain, if the model supports it, the LangChain API has an abstraction for understanding how many tokens you're using, input tokens, output tokens, and your total tokens, and then you can estimate price. So as of the last time I checked, which was back in January, for GPT-4o, it was like $2.50 per million input tokens and $10 per output token. So you can start to calculate how much stuff costs. So if I ran this one where I sent it a message and you sent it a few messages back and forth, it used 41 input tokens, 5 output tokens for a total of 46. And this is how much USD that call cost, which not a lot, fractions of pennies. Like I said, I've been doing this talk now for several months, and I've started with $5 and I've still got a couple dollars in my OpenAI account. And different models have different pricing structures. Any questions about that? Muaf, just quickly, are we going 90 minutes here or 60 minutes? I'm assuming 90. Yes.
Yeah. We're going 90 minutes. No problem.
90 minutes. 90 minutes. All right. Cool. All right. So let's talk about these AI services. We've kind of shown how you can use these models kind of from the declarative approach. And honestly, if you were to look at Spring AI, it would look very similar to this. You'd have an object which represents the model, or you'd have to use a builder to build the object yourself, kind of like in here, you'd get injected like I don't know what the AI bean is called, but some builder, kind of like REST template builder, and you do something you call build on it, and it will give you the object. And then you could use that as a bean and inject that as a bean. Similar with Quarkus, you can just inject the chat model. With the Spring Boot support for LangChain4j, you can just auto wire the model, but it's the same chat model, and that's kind of similar to how Spring AI works as well. Something Spring AI doesn't have, which I like a lot, is this kind of higher level abstraction called an AI service. So the underlying API using the chat model, the API is predefined. The names of the methods are predefined. With this AI service now, you can start to build your AI interactions with nomenclatures that are based on your business domain or whatever problem you're trying to solve. So in this case, we have we define an interface and we call it assistant. You can call it whatever you want. You can define whatever methods you want, name them whatever you want. If you just give it one string method, that becomes your user message. And then you give it the string output, and that's the output of it. And then you can, using LangChain4j, you can create instances of these interfaces, and it will actually implement the underlying models and stuff for you. So you give it an instance of your model, and then you create it, and then you can just call the methods directly on your interface. You don't need a handle to the actual model anymore. And it'll generate this implementation for you. Oops. So let's see an example of that. if I go, let's see, AI services, simple service. So here's a simple service. So I define my assistant, and then I use this AI services thing that comes from LangChain4j. I create an instance of it, and then I can just call the methods on it. So I'm back to 1. Right. And I'm injecting the model as a bean because it's configured, and say answer hello world. So like I said, by default, that this is the kind of the simplest use case. You have to have at least one string parameter unless you just don't want a user message. You know, if it's just one parameter, it's a string that becomes a user message. The string becomes the output, and there's no system message in this case. So that's about as simple as it gets. Right. So if you want to define a system message, you can define a system message, and you can do that in a few different ways. So one way, got the code up here. So one way to do it is you can define the system. There's a system message annotation. You can put it on the method, and that will define the system message just for that operation. You could define multiple operations. So string, another answer, oops, not assert, serve for a question. And if I did this answer method would have the system message, but this other method would not. And so you can start to define it that way. So if I go, oops, and then I run it. And Shakespeare, all your responses must be an iambic pentameter. So here's my answer, blah, 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 blah. So if I add another, oops, answer 2, like here, and then I rerun it. So the answer 2 is just hello world. It's not an iambic pentameter, right? Versus if I took this system message and I put it at the class level, now all the operations get it, right? So kind of you get this level of inheritance. You can also do it programmatically if you wanted to, rather than using annotations. If you don't like using annotations, you can, when you build your services builder, you can provide the system message as part of the builder as well. Using the builder approach, there's no way to do it on a per method basis. It's kind of like an all or nothing thing. So one of the questions is, can you dynamically switch between models at runtime? Yes, you can, and I'll show different ways to do that. It's different based on whether you're doing upstream LangChain4j or not. If you're doing just pure LangChain4j, you would build different chat model instances for each model that you were using. And then you'd have to devise a way to switch between them. In Quarkus, there's a, so if you define different models in your configuration, you can do something. We'll talk about Quarkus in a minute, but there's an annotation you can use that tell it which model to use. Now, what's interesting is each assistant or each interface that you build is tied to one model. So all the operations in there are tied to one model. You could build multiple interfaces, and each one is tied to a different model or to the same model. So that's how you could start to separate. And then you could define like an object hierarchy structure and then use dependency injection to inject the right one, the way you would with like polymorphism and whatnot. So again, more kind of syntactic sugar that the frameworks add on top of it. So parameters. So you might start to think, okay, this annotation stuff is kind of cool, but what if I wanted to make my user message specific to something that's parameterized, right? So in this case, I have a poet. I'm Shakespeare. All your responses must be iambic pentameter. I want to write a poem about some topic. It shouldn't be more than 5 lines long, and it should use some language. And in this case, I'm going to say I want to use the Riad jug, and I want it to be in French. I don't know why you want that combination, but we'll go with it. Oops. Right. So now when I run this, you see the answer is about Riyadh, and it's in French. And I could change this to, instead of French, I want it English. So now I don't have to actually change my prompt. I can inject parameters into it. And the way you do that with straight LangChain4j is now your method can take in parameters, and you use this @v annotation to define what the parameter name is, and then the template is written in Mustache. So if you're familiar with Mustache, it uses Mustache for its templating language. So that's kind of neat. So now it's in English. You can even use parameters in your system message as well. So instead of defining your user message, when you do it this way, you can't define the user message, as part of a string here in the method signature anymore. You have to define the user message as an annotation. Or you could define the user message up at the top. If you only have one operation, you could do it at the interface level. So how this is named @v, don't ask. I don't know. Developers are awesome at naming stuff. Someone probably put this in as a placeholder thinking, hey, I need to rename this thing, and it made it into the release. So, it's kind of a dumb name, but that's the annotation. Something like Quarkus or Spring Boot, when you use this on top of it, and I'll show it in a minute, you don't even need the annotation. It can understand the method signature. Yeah, v variable, v value, you kind of name it, think of whatever name you want. But again, when you're using something like Quarkus, you don't even need the annotation anymore because it understands the binding between your method attributes and the templates. And I'll talk about that in a second. All right. So the next thing that's kind of interesting is, so far we've only been talking about strings, right? Spring sounds very similar. So everything returns string. And I kind of mentioned that in Java, we're used to strongly typed things, right? So instead of returning strings, maybe I want to return some more complex structure. So in this case, it's a record, and that record has two things in it, one being a string and one being this enum. And so now when I set up this interface, I can say, I can return an object of this type, which is something you can't do if you're just using the generic chat model. Chat model takes a string, returns a string, and then it would be up to you to use Jackson or JSON or whatever you wanted to do the marshalling. Under the covers, LangChain4j uses Jackson, so it'll use Jackson to build a mapper for this object, and it'll also maybe it'll do it in the thing. Let me see if it'll, when I run this. Oops. When I run this, if I turn on the logging, so let me turn on Quarkus LangChain. Oops. Log. I'm just going to turn on request logging so you can kind of see what's going on behind the scenes here. If I run this again, you can now see it's outputting the log, and you can see the messages. So here's a system message. An AI needs to triage user feedback, analyze the user feedback, then provide a summary of the feedback. And here's the feedback. It was a great experience, because that's what I asked it, right? It was a great experience. But now notice it also puts in now, it's a technique called prompt stuffing, is LangChain4j, because I'm returning something that's not a string, it can understand the structure of that thing, and it says you must answer strictly in the following JSON format, and it gives it an example of what the JSON looks like. And so now the LLM can answer. Will the LLM always answer in that format? No. So that's another thing that we've, something that could go wrong. I find that the models that you pay for, like Claude and GPT and Gemini, are all pretty good. Most of the time, do the right thing. If you're running models locally with like a llama or something, then your mileage may vary. Sometimes it's okay, sometimes it's not. So we'll talk about strategies later for how to deal with that. But for now, it's possible, but because the model is non-deterministic, it doesn't always work, and it's not your fault, right? I kind of see these models, and I don't know if anybody has children. I have two kids. I have an 18-year-old and a 14-year-old. And if you've ever had teenagers, I say like a 12-year-old, but if you've ever had teenagers, or you were a teenager at one point, think about, you have a teenager and you want them to get to do something. You want them to perform a task, but you only want them to perform that task. Don't do anything more. Don't do anything less. Just do exactly what I tell you. So if you start your your instruction too generic, then there's room for error, right? And as you figure out that you have to make it more and more specific to what you want. And these models, I find, are exactly the same way. If I think of how I want to structure my prompts, like I'm talking to a 12-year-old, I tend to get better results because I tend to be more explicit. You know, the more explicit and the more targeted you can be, the better the results you're going to be, generally speaking, right? So yeah, so you don't always have to return strings. You can start to combine objects. And this is something that the AI service gives you to be able to do. Yeah, so messages. So again, that message, I'm not going to do a code, but we talked about message windows before. You can build your message windows right in, or your memory management right into the system. So now you can define how the memory management is going to work for your service. All right. So any questions about that? And I'm going to kind of dive into what Quarkus does on top of that. What am I doing for time? I got a half an hour. All right. So let's talk about. So if you think about, I started talking about this a little bit. If you think about your applications and your application integration. So with your CRUD applications, you've got an application that talks to a database, or you've got some microservice that talks to another service. And now we've got these AI-infused applications, and these things talk to models. What's the difference between these pictures, right? The point of where your application talks to something else is an integration point. And all integration points always need things like observability. You need to be able to trace and do distributed tracing. You need a way to do auditing. You need a way to capture metrics. Is it slow? Is it overloaded? You need fault tolerance. Do you want to apply timeouts? Do you want to apply retry policies? Do you want to apply rate limiting? Rate limiting is an interesting one because most models will rate limit you. You can only make so many requests per hour. And maybe you want to build that into your application logic and using some of the fault tolerance capabilities. I remember when all the Netflix stuff first came out, circuit breaking and bulkheads and all that fun stuff, we would start to use it all the time, and then we never did in our applications anymore. If you think about how many applications you build today where you actually use timeouts and circuit breaking and rate limiting and fallbacks and bulkheads, it's probably in the minority for most of your applications. I'd say for these AI-infused applications, they're super important because of the non-deterministic nature. Things are going to go wrong, and you can't code around every possible thing that could potentially go wrong. Things are going to go wrong. The model is going to misbehave. The model is going to give you an answer you don't expect because it's non-deterministic, and your application cannot crash because of it. So these things become super, super important. So when we start using these AI services, with Quarkus, as I've shown, you can just directly inject the model and use it directly. But Quarkus starts to where it really becomes powerful is when you use these AI services. So Quarkus almost, I won't say it forces you, but it strongly suggests, I guess is the right phrase, strongly suggests that you do it that way, because when you do it that way, you get kind of all this other stuff for free when you do it. So you define your interface, you configure the prompts, you can configure tools per certain, we'll talk about tools in a bit, and you get out of the box CDI, you get dependency injection, you get memory management, you get tools and agents and RAG integration and observability and auditing and all this stuff. You just kind of get it out of the box for free. So if you have like open telemetry on your class path, you'll get open telemetry metrics and observability and distributed tracing, and all those back and forth calls with the models will automatically be traced and all that stuff. It's just all built in. So let's look at an example here. Yeah, very basic level. So here's a simple one. Right, so I have, and you can kind of ignore this request context thing for now. So I have my assistant, and it looks kind of like straight LangChain4j, but the only difference is I have this annotation on it called register AI service, and this comes from Quarkus. And you notice now I don't have to do like that. If I go back to this first example here, where we're just using straight LangChain4j, or I have to do this AI services.create, pass it a reference to the model, inject the model. You don't have to do any of that because Quarkus will just the fact that you've tagged it, it knows you've configured a model, and if it doesn't, you'll get an error. And then it will build an instance of this, and it'll make it available as a bean that you can then inject. So you don't need to know like how to build it or anything like that. Quarkus will take care of all that for you. You can just build your interface and start using it. So there's a question, what are the performance when using Y? I think that's a different question. Let's tackle that later, if you don't mind, because it's not really related to the code itself. But let's circle back to that question. So now if I run this, Quarkus dev clean, excuse me, my name is Kamant. Can you say hello world in Greek to make Georgios happy? Sure, hello world in Greek. And I don't know if anybody speaks Greek. I don't, but I don't know if that's actually true. And then what's my name? And it says your name is Kamant because it's in the message history, right? Because by default, if you don't tell it how to configure the message history, I think it uses in some unlimited space or uses in memory messaging, and which it's probably not. You probably don't want the default in production, right? So let's talk about scoping and memory, right? So by default, let's talk about scope. So if you start to think about, say I'm building a RESTful application, right, where it's just taking REST requests, and as part of that incoming REST request, right, I have assistants, right? I have different assistants, and say, you know, every HTTP request that comes in, you want an assistant. You could have an assistant that's either scoped for the request or is scoped for, like, I'll say singleton, or for the one instance for the entire application, right? So by default, these assistants become request scoped. So every HTTP request that comes in will get an instance of the assistant, and by an instance of the assistant means the memory management and everything that comes with it on a per request basis. Versus if I tag it, so application scoped, if you're not familiar with context dependency injection, if you're comparing to Spring, is the same as a singleton. It's one instance per application, which, you know, application scoped, kind of where the name comes from. Now, if I have multiple requests that come in and I'm using an application scoped assistant, now I've got one instance of that, and now memory becomes super important, because if I don't manage memory, like if I don't inject some memory identifier, then you're essentially leaking conversations between users and between requests, right? So in this case, you know, I can define some memory ID, and it can be whatever you want it to be, and there's strategies for how to do this. We'll talk about that later, but you can have one assistant that scopes its memory by some key that you derive. So maybe you're dealing with users and you want the user to be the key, or something. Think of it as like a cache. The other interesting thing is when we start talking about like chatbots, is like kind of the advent of WebSockets, right? And so WebSockets are kind of unique, where when you go to a web page and you talk to some, like here, let me show. I'm gonna fire this guy up. So if you've never used Quarkus before, Quarkus has this thing called dev mode, which is what I keep running this thing. One of the cool things about dev mode is that this dev UI, if I just hit the D key, and then I'll make this bigger, you get this little developer UI that's in here. So if you're building a WebSocket, you don't necessarily have to build a user interface for it, because Quarkus will give you one out of the box for free. And so now I can connect to that WebSocket, and now I can start interacting with the WebSocket. I can say, hello, my name is Eric, right? And it says, hello, Eric, how can I assist you today? What is my name? Your name is Eric, right? So that's cool. So now if I go back and I close this connection, and if I'm a new client and I come to this and I open a new connection and I say, what's my name? It doesn't know, right? Because each WebSocket, the WebSocket protocol on the server side, each connection has its own session. And so now when I build my assistants, I want to build a conversational assistant. And so now I can just tag it with session scope. So if I have session scope, which is a standard CDI scope, and I'm using WebSockets, Quarkus kind of understands the relationships, and now it'll bind instances of your assistant directly to a WebSocket session. And when the WebSocket session closes, it'll destroy the assistant, right? So that's kind of stuff now that you don't have to worry about, the managing the state and managing the memory and the messages. There's also, like if I wanted to show, because I have Swagger and I am building REST endpoints, close this connection, go back. What happened? Did I stop? Yeah, so if I come back here and I come to my Swagger UI, so if you're not familiar with the Quarkus Dev UI, every extension you have can provide a card in the Dev UI here. So in the case of like CDI and LangChain4j, contribute stuff, REST endpoints, there's a whole bunch of stuff. One of them is the WebSocket extension. When you start building WebSockets, we'll bring in this that user interface that I showed. If you got the Swagger UI or the OpenAI Open API extension, you get this card. And so now I can start to say, I can start interacting with the Swagger UI live. So I can say, hi, I'm Eric. So this is the one that's using the per request. Hi, Eric, how can I help you? What's my name? It doesn't know my name, right? But if I go to the other endpoint that uses the application scope, I can say, okay, for hi, I'm Eric. It says, hi, how can I assist you today? What's my name? Your name is Eric. But then if I go away and I refresh the page, right, and I come back, because I'm using the same key, kind of like in cache, and I say, what's my name? Right, it says your name. It still knows because I'm using the same key. So even though it's a different request, it's a singleton bean that's using the same key. So now I'm sharing message windows and conversations across requests. So it's stuff you kind of have to keep in mind a little bit. All right, so memory. So we talked about there's a couple built-in ways to do memory management. There's the message window, and there's that default one, but you can also build it. You know, it's got an interface that you can build itself, that you can build implementations of. And in I think the example I have is I tied it to Redis or something. What did I do here? Yeah, I bound it to Redis. So in my case here, I've got my assistant is request scoped, and then in my configuration, I have Redis, just the Redis client on my class path. I made it a bean. Quarkus will automatically see that I have a single bean of type chat memory store, and will automatically pull that in. I don't need to do any configuration. It just sees that I've provided my own chat memory store bean, and it'll use it. So it just uses the Redis API, the Redis data source API. So now I have a memory store which is using Redis for managing the conversation state. So it's pretty easy to bind if you wanted to use Postgres. I think there's a couple built-in ones like for known databases like Postgres and whatnot for doing this. Actually, the Redis one is built in already to Quarkus. You wouldn't even have to build that anymore. We just built it to show an example. All right, structured output. So let's revisit structured output. So we showed with LangChain4j that you can use templates, right? Well, similar thing with Quarkus, you can use templates. The only difference is in LangChain4j, you had double brackets. And in Quarkus, you just have single brackets. That's because Quarkus swaps out the templating library or the templating language. So in LangChain4j, it's Mustache, and Quarkus has its own templating language called Qt. And the difference being with Quarkus being so build time driven, Quarkus will actually validate the parameters in your templates at build time. So like if I changed this and I didn't provide a parameter called num, that'll actually be a compile time failure because Quarkus validates templates at build time, not at runtime. So you can do all kinds of stuff here, and you can even get you can use higher level objects. So if I have a record, an object that has fields, you can reference those objects and fields. I can reference methods. There's all kinds of cool customization stuff that I can do in there. I could even do loops, and if I wanted to include the whole chat history in my system message or in one of my prompts, I could do that too. Why you would want to do this, I don't know, but you can call methods. You can do all kinds of stuff in the templates. All right, so we talked about some of these other capabilities. Let's talk about observability, and this is actually pretty cool here. So if I go and open my observability stack here, so I have my assistant, right? Register, you're a useful assistant expert in the NBA. What are the last team in which some player played? Return the name of the team, and it comes as an HTTP endpoint. So if I run this guy, so Quarkus also has this thing called dev services, which will automatically start up containers based on what you're trying to do. And in this case, I have the OpenTelemetry extension. So there's a dev service for OpenTelemetry, which has the whole observability stack. So Loki, Pyroscope, Tempo, the OTel collector, Grafana, Prometheus. It will start all of those things automatically. So now my app is up. If I come and I go to where's Swire UI, I come to my NBA. Let's say try it out. And so the player, so I'm in the Boston area. I'm going to say Larry Bird. All right. So I got Larry Bird last played for the Boston Celtics from 1991 to 1992. But if I go back to my dev UI, where I see my observability tile here, because I get this from the OpenTelemetry, I can click on the Grafana UI, and then I can go into Explore, make this bigger. I don't really like the Grafana UI. I can go to Tempo. And if I do a search, I can find my application, and I want to look for the post to the /NBA, right? Because that's the operation. And so I've got one span here, and if I bring this bigger, I can start to see. So it went down into my assistant. And there's some attributes here. Here's the resource. And then that assistant made a completion call to GPT-4o. And it actually calculated, because OpenAI has an API for doing calculations. So Quarkus will automatically do the calculation as to how much that call cost, and it adds it as a span attribute. So you can start to see all the different traces and times and everything, and you just kind of get that out of the box. And here's, it went to the OpenAI chat completions. Here's the attributes and the versions of stuff and the payloads and all that stuff. So you get all that for free out of the box. All right, and this is just screenshots of what I just showed you. And auditing, and actually there's more. I'm going to update this slide. There's more audits. So another thing that Quarkus provides is this auditing capability. And the way I like to introduce this is, if I were to ask you, if you're using AI and you're using some model, right? And you change your model, or you change your code, or you change your parameters, or you change your prompt, how do you know if you got better? Well, the only way to know if you got better is to have a way to know what you were doing in the first place, like capturing, answer questions and answers, and being able to retrieve them after the fact. And so that's one reason where auditing comes in. So Quarkus will expose a number of different events that you can capture. So when the messages are created, when an interaction is complete, if an interaction fails, when any response from an LLM, whether it's a tool call or a chat response, it doesn't matter. Anytime the LLM gives you a response, you can look for that. Anytime a tool is executed, There's also guardrail. We haven't talked about guardrails. There's other guardrail events in here and whatnot. But you can observe and intercept these events, and you can do things with them. So you could store them in a database or you know, whatever you wanted to do here. So if I run this guy, here's my endpoint here. All right, so if I were to run this, oops. I'm gonna go back to my dev UI and go to Swagger UI and go to my endpoint. All right, and again, I'm gonna ask about, let's now do Michael Jordan, right? Michael Jordan. And say he last played for the Washington Wizards 2001 to 2003. So that we got that answer, but what did we see in our log? And my audit listener is just logging stuff to the console, nothing fancy, but you can start to see, here's where the initial messages were created. Here's the source, here's the system message, a user message. I got a response back from the LLM. The whole interaction was complete. Here's the source, here's the user message, here's the system message, here's all the parameters that were in it, here's the result. All that stuff is part of the auditing trail that you can now start to do stuff with. Again, this is again something that we're actually going to move this or bring this up to the community LangChain4j. So a lot of times when we build these capabilities, we build them in Quarkus first because Quarkus moves really fast and we can iterate really fast and we have a pretty big user base. And then we let the feature bake there for a little bit and we tune them. And then when it becomes kind of stable, then we'll actually contribute that feature upstream to the upstream LangChain4j. And then we'll kind of replace the Quarkus implementation for that. And so auditing is actually on I built the auditing feature in Quarkus LangChain4j, and it's on my to-do list to move upstream. Can you integrate with Datadog? Absolutely. You could do whatever you wanted to do. So you could you receive this event and you can do whatever you want with it at that point. It's your own code that's executing. So Datadog, you could integrate it with OpenTelemetry and send OpenTelemetry to a Datadog collector. You could use Micrometer to export it to Datadog. There's lots of different things you could do. Right? So this, you could start to see latency for your request. Every time you capture an event, you could capture the latency and how you can start to watch whether requests are taking a long time. There's lots of different stuff you can do. And then you can do fault tolerance. So we talked a little bit about fault tolerance. So Quarkus has fault tolerance just built in using the microprofile fault tolerance spec. So I can build one of these assistants and I can tag retries and timeouts and rate limits and fallback methods and be able to start to do some kind of error handling, and all of this will get respected on the interaction. And you can even define these through properties as well. So I could change the number of retries based on what environment, if I was in production or development or whatever. Rate limit, I could do circuit breaking. If I'm using a local model that's being served inside my organization and I know it's going to be down, well, don't send requests to something that you know is broken. So you could use circuit breakers to do that. And again, this stuff becomes super important when we start talking about all this non-deterministic stuff. I think I got a couple minutes left. I think we have time for this images section, and then I think we'll be out of time after that. So when we talk about images, we're talking about things that are not text. So specifically generating images from text or processing, generating images from a text prompt or generating text from an image, vice versa. So kind of like old school OCR. The challenge here is you need to have a model that supports this. So like OpenAI, for example, when you send a request to OpenAI, it can actually do this, and it makes it look like it's the same model, but it's actually not under the covers. It's OpenAI will expose as the same, OpenAI exposes a single endpoint that supports both text and image, but under the covers, there's actually different models that serve those requests, and it's not just the model, it's actually the serving runtime has to support this as well, because the API is totally different. So So like if you're using VLLM, it supports it, and some of the other model serving runtimes. Ollama supports some of the models on Ollama, but the Ollama runtime supports it. Ramalama, I think, supports it. But so depending on the runtime, it may or may not support it as well. And so this actually gets to be pretty easy to do. Where's images? Images. Actually, I changed the order, so images are number 7. I changed my order a little, so I'm a little out of order here, but I rearranged the slides a little bit. So if I have an image model, the image model is another thing that I can inject, and I can use it and just say generate it from a prompt, right? Or if I want to do it through the AI service, rather than using the lower level things, I can create an AI service. And if I want to generate an image from a prompt, I can just say, create my method, call it whatever I want, give it a user message. And then this image object comes from LangChain4j. And it has, I can tell it, do I want it to give a URL? Do I want it to give me all the base 64 data? You know, what is it, a GIF or a PNG? And sometimes, depending on the model, will actually give you like a little synopsis of the image. It'll take like your user message and like give you a summary of what the image actually is. And if you want to go the other way, you build a method and you give it a user message, describe the image, and then you can give it a string or a URI or a URL or the fully encoded base 64 data, and you tag it with image URL, and it'll actually give you a description of what that image looks like. So in this case, if I go to 7, 2. So my example here, so I have a prompt, generate a picture of a rabbit going to Riyadh. It should be wearing a Quarkus t-shirt. Then I'm going to have it generate an image, and then I'm going to get a reference to that image, and then I'm going to actually have it describe the image to me. So let's see what happens here. I'll have it generate an image and then describe it back to me. So here's the outgoing. You see I'm using the Dall-E model, generate a picture of a rabbit, should be wearing, return it in the following structure. I want it 1024 by 1024, standard quality, vivid, and I want the URL. I don't want the whole base 64 data. Because then I'm going to actually I'm going to write that URL out to a file. And then it's going to take that file. Yep, here's the file. And then it's going to take that file and it's going to say, hey, describe the image, and here's the URL, that it gave me before, and have it go describe it. And then so it comes back and says, this image features a cartoon style rabbit with large ears wearing a green shirt that has a science symbol on it. Rabbit is standing next to a sign that reads Riyadh on both Arabic and English, indicating a journey to Riyadh. The background, blah, blah, blah. So let's see what it actually did. Where did it put it? Let's see if that's right. Here's the image. Right here. Rabbit at Riyadh. Yep, so that's the image it generated, and then it generated this description from it. Below the sign, label with the word Quarkus, and additional text appears to be a similar format, noting Saudi Abba. Overall, the design is colorful, playful, likely intended for a casual or travel theme context. All right. So we just showed that. And then you can control, in Quarkus, you can control, like for the image model, the size, like if you want it bigger, smaller, the quality, style. There's some, if you wanted to, Quarkus can actually save the file for you without you having to do it yourself. So there's some configuration options in there. And then same with generating, doing the same thing. I think that about brings us to time. So I said at the beginning, we would probably get to RAG, and that's about where we got in 90 minutes. So unfortunately for me, I feel like this is where it starts to get interesting. Like that's all the basics and the building blocks on how to do stuff. And now when you start getting into RAG and MCP and agentic workflows and all that, this is kind of like the fun stuff. And this is the stuff that's evolving at like the pace of lightning, and that every time I do this talk is different. So I think at this point we're going to have to stop, but I'm definitely happy to come back and pick up from here another day.
Yes, absolutely. Thank you so much, Eric. It's really wonderful stuff. So many content has been like shared here. Really appreciate this talk. I have a couple of questions from my mind, if you don't mind.
Yeah, absolutely.
Yeah, now I had this question really early, but I don't have the answer. So some guys they say now LangChain4j is it like tightly coupled with LangChain, which is the main one, meaning that if there are they will keep watching the features in LangChain, then they will replicate these features in LangChain4j, or they are completely different.
They are completely different. No, zero relationship whatsoever, other than it started, LangChain4j started using kind of the same concepts of providing layers of abstraction. But other than that, they're completely, they have different maintainers, different release. There's no cross communication or collaboration because they're just different. Like the way Python does something is in the way the paradigms and for Python and JavaScript is completely different than Java, especially when you start getting into like dependency injection and all that kind of stuff. So they're completely separate. They're totally different things. They just happen to share a name, which is actually going to change. It's going to get renamed to something else because of that. Usually.
Yeah, it should be. It should be changed. Yeah. What about the features? Are we like in Java? Are we like waiting for the features to be released in LangChain Python? Then we copy them into LangChain, or we just have our road?
No, we have our own road. LangChain4j has its own roadmap and does what it wants. A lot of the major, so like the model providers, so like Google Gemini and the Microsoft Azure stuff, all that stuff is built, like all the Gemini integration and Vertex is built by Google. And all the Microsoft Azure stuff is actually contributed to by Microsoft. So we have all the big players that provide these capabilities, like Milvus and Pinecone are actually contributing their integrations into this. So it's not just like it's a community project, but it's pretty well thought about, and it has its own roadmap and it has its own release cadence and kind of goes where it wants to go and based on what the ecosystem is. And this ecosystem evolves like it's insane, like the pace. Like think of like a year ago, like even at the beginning of this year, like what was MCP? If you had said MCP in January, they'd be like, what are you talking about?
Yes, good stuff. So like from your experience, do we see any LangChain4j like production ready, in production is working now, or still it's under development?
No, I mean, version 1.0 is an LTS and it was released a while ago. 1.2 was just released yesterday.
Yes.
So it's on a release cadence. IBM is actually productizing it and going to support it as part of one of their offering. When I don't know, I'm not privy. It's above my pay grade, but I know they're working on actually productizing and going to have support and like paid support for LangChain4j. What that looks like, I don't know. I just know it's in the works.
Yeah, nice. But till now, like, I don't think so. Like, there is a real company use it in their like production systems. Maybe.
I'm pretty sure there are. I don't know who they are, but I mean, I talk to people and they're like, "Oh yeah, we use it all the time. We've been using it for a long time." I don't have any names that I know off the top of my head, but I know people are using it. It's got a very big community.
Yeah, for sure. Like it supports also, but I think we didn't come to this topic, which is agentic applications. Of course, we can build wonderful agentic application using LangChain4j. That's what we're gonna see in the part 2.
Part 2. That'll be in part 2. You got to understand the concepts. I like to take this like maybe a year from now. I won't have to do this first part where I have to teach people the concepts. But it's kind of like anything new, you know, someone coming, I like to assume that people don't know anything.
Awesome. That's really wonderful. Amazing. I'd love really to see Java into the AI, which we are seeing right now. I think there are no extra questions with this. I would like to thank Eric. Thank you, Eric, so much for this time and for this wonderful session. And also would like to thank our audience. I think we have like so much really interest in this. We have seen the meetup is like everybody is registered into this meetup, and also the video is recorded, so you can go back to the video recording in YouTube. Any final words, Eric?
No, that's I'm happy to. I was happy to be here. To meet people. Maybe someday I can make it over there in person. It'd be an awesome trip.
Yeah. Most
So I'm happy to set up a time to come back and do part 2, maybe after summer's over.
Sure. All right. Thank you so much, guys. I'll see you. Looking forward to seeing you again.